Everyone, it's always great to have the last slot of the conference between this and you going to a party. I'm the only thing that's basically stopping you. So anyhow, I'm going to talk a little bit about infrastructure as code on Azure. And I want to make clear that it is Azure specific. My opinions might be a little bit different, and I might weave off that a little bit during the talk as well, but most of it is about Azure as such. My name is Chris Klug. I work at a company called Active Solution in Stockholm, where I do, this is going to sound bad, but basically anything they pay me for, which mostly means I work as a software developer or architect, and for the last 2-3 years something, I've been doing DevOps and infrastructure as code basically full-time. And then I also travel around at conferences and open my mouth. I was told to put this slide in here as well before I did the rest of it. That should probably have been in English, sorry about that. After party. After the conference, when I shut up, there is a party. There will be grown-up things to drink, and there will be food and music. So please stick around for that. With the fun stuff out of the way, let's get back to code. So before we get started, when you start looking at infrastructure as code, you have to think about imperative versus declarative, right? There are two ways of doing infrastructure as code, or IaC, and imperative means that we write programs that tell the system what to do. Like if you use Azure CLI or you use PowerShell commands, you go and say, go and create X, go and create Y, go and create Z. Problem with the imperative coding is that you also have to go and say, go and create X. Oh, by the way, no, wait, back up. Does X exist? Yes, then don't do this. Doesn't exist, then go and create it. And then you get all of these really complicated if-else branches in your code to figure out how to get the environment up and running. And when you try to add something new in there, somewhere you have to figure out to do another branch to figure out that, oh, that new thing needs to be put in there as well. And also you have to take care of like, what happens if something fails and how do I roll back this and how do I blah, blah, blah. So we can do infrastructure as code with purely like PowerShell or Bash and Azure CLI and PowerShell, PowerShell commands for commandlets for Azure, but it's going to be complicated. So I'm not going to touch that. If you're doing that today, go ahead. But I would recommend looking at something else, if we put it politely. It's better than nothing, but doing it declaratively is different, because when we do it declaratively, we basically go and say, this is the environment that I want. I declare what I need, and then I take that declaration of what I need and I give it to someone else, and that someone else is not someone I know. Basically, I give it to Azure, or I give it to Pulumi, or I give it to Terraform, and I say, this is what I need. And then that other thing goes and says, oh, you want it to look like that. Let me take what you told me what it should look like and compare it to what you have today and figure out everything I need to do to make your current situation look like the thing that you need. Much, much better. So I'm going to focus on that because imperative is just a pain in the butt, to be perfectly honest. Especially if you're on Azure, because if you like using the Azure CLI, like I personally prefer the Azure CLI over PowerShell, is that it is almost idempotent. So idempotent means that you can run it over and over again and it doesn't change anything. Problem with Azure CLI is that 90% of it is idempotent and you can run it multiple times, but 10% of the commands are not. So you have to sit there and figure out which will run multiple times and which won't and so on. Declarative, much, much better. So I'm going to focus on these three options, because those are the only three options I find to be reasonable for Azure if you're on the .NET platform and you're not an F# person, because apparently if you do F# you can do other stuff with, for example, Farmer. But if you've got Bicep, we've got Terraform, and we've got Pulumi. And they're all interesting in their own ways, and the showdown part of it is which one should you choose? Which one would be better than the other when you start doing your IaC stuff? But I guess before we go any further, why am I not bringing up ARM templates? Has anyone ever worked with ARM templates? Does any of you want to explain why I don't want to mention ARM templates? Because anyone who's ever worked with ARM templates, do get this urge to stop working in IT. So I'm not touching that. So we're just going to leave that out of it. They work, stop using them. So comparing frameworks is interesting. I sat down and I thought this was going to be a really cool talk, very interesting talk in my mind. And I do workshops on this as well. So we do a full day and a 2-day workshop where you get to try the different things and compare them and everything. So I thought, let's boil it down to a conference talk. And it's like, how do you compare frameworks? What are the important things? So I came up with this. To me, the most important parts are these. How do we get started? Might not be very important in the long run, to be perfectly honest. Who the hell cares if it takes ages to get started the first time you run it, if it's really, really efficient afterwards. But the thing is, if you go home after this talk and you want to try something, and it takes you 6 hours to get the tool working, you're not going to be working with that tool, because you're going to give up way before that, and then you're going to tweet me and say that I'm a moron for suggesting it. So that getting started is important. Using the framework, how hard is it to use? Is it complicated? Do you have to be a brainiac and have like a computer science degree, or can you be a nobody who's never learned anything but JavaScript and still work with it? Yes, that's important. Having that said, I don't have a computer science degree, so I'm the nobody with a JavaScript framework. Syntax. Syntax might not be important, but I suffer from weird OCD things, right? If it doesn't look good, I can't work with it. Syntax must be readable, look okay, and not be dumb. There's like literally dumb stuff out there, so don't touch that. So that's important. Extensibility, yes, you are going to be building things that probably is different from what everyone else is building, because your situation is probably somewhat unique in some way in some cases. Have they covered your unique stuff in the tool, or can you extend the tool to do the things that you need as well, because you might have some unique needs? That's important. Are there unique features in the tool that's like, oh, this is really cool, this gives you this awesome power stuff that the other tools don't work, that can be useful? Most of that turns into be gimmicky stuff that looks cool on the surface and on a PowerPoint slide, and then in the end you never use it. And finally, annoyances. Yes, one of the tools I'm going to talk about today has an annoyance to the point where I'm considering taking it off an option as the most usable tool because it has that one thing. So I want to cover those things as well. But we'll start out with Bicep. So how many of you have tried Bicep? A few of you? Okay, cool. So before we go into Bicep as such, ARM versus Bicep. So what's the difference? Why is one thing that... So Bicep is an extension or a continuation of ARM. Actually, the Bicep is not a continuation of the ARM, but yeah, you get the point. It started out with ARM templates, and you got the ARM Azure Resource Manager in the cloud. You tell the Azure Resource Manager whatever resources you want to have in the cloud, and it manages all resources in the cloud except for the ones that are called classic in the portal, which are basically code word for don't use this. But everything else goes through ARM templates, or ARM. And ARM in the cloud only understands ARM templates. It only understands JSON-based ARM templates. That's it. It has no knowledge whatsoever of Bicep. So what they've done with Bicep is they've created a better syntax, much shorter, simpler, easier to use syntax. And what they do is they transpile that Bicep syntax into ARM templates, and then they push the ARM templates to Azure, and then that generates resources. Kind of good to know, for the very simple reason that when stuff happens and stuff fails, the errors you're going to get is going to be based around the ARM templates, not around your Bicep. So the syntax from your errors is sometimes going to be a little bit weird to figure out compared to the Bicep stuff that you have written. So what's it like to getting started with Bicep? Bicep is awesome because all you need to do is install the Azure CLI or Azure PowerShell commandlets, which most of us, I would assume, already have installed if you do work with Azure. You log in to get access. That's about it. And then you write your Bicep template, which is, I guess, the important part, but you write your template, which is just a text file. And then finally, you just run a little command like that, and you say AC deployment, what target you want, what template to create, and then what template file you want to use. Or you can use the PowerShell commandlet new AC resource, and it just takes a few minutes to run, and then it comes back and says everything is done, and you go in and everything is up and running for you in Azure, which is quite neat. So getting started with Bicep is ridiculously simple. It actually depends on another application called bicep.exe, which is the thing that transpiles from Bicep to ARM. But once you run these commands, AC deployment or a new AC resource, it will automatically download and install bicep.exe on your machine, so it's available on your machine, so you don't have to do anything but run those commands and you're good to go. Using the tool, fairly simple. I'm going to show you the Azure CLI commands only. But they're all around AC deployment, and then you could go and say, I want to deploy to a resource group. You can deploy to other levels as well. So you can either say, I want to deploy all my resources into one resource group, which is the default way of doing it, or you can say, I want to deploy at a higher level and create my own resource group. So if you want to have more than one resource group in your deployment, you go level up and say, I want to do subscription deployment. And then you go create, like any other Azure CLI command, you basically say what you want, create, give it the resource group name and the file name. That's it. Done. Execute. You can also add a -what-if at the end, and that will tell you what happens if you run that command for real without the what-if, and give you, this is what's going to happen. And it's going to suck. It is by far the worst implementation of that of any of the three. All three has that support, but when you do it, it will come out and say, I'm going to change this for you, and in reality, it's going to change that for you. For some reason, it just figures out all of these things sometimes that it needs to change that won't actually change. So the what-if thingy, it works-ish, but you need to read through it and sort of figure it out. It's just not that great. That's all the commands that you need, actually. Then there are two little commands down here that I really like. You can do IaC bicep build, give it a bicep file, and it will output an ARM template for you. So if you, for some reason, want your eyes to bleed, you can get the ARM template and look at that. Or, that feature is not as useful as this feature. If you already have a bunch of ARM templates, you do decompile, and you give it the ARM template, and poof, you have a bicep file. Then you take your ARM file, you throw it out, and then you replace it with Bicep. That's all you have to do. So you just do that for all your ARM templates, and you're good to go. And the reason that there are no other things you can do here is because the tool doesn't do anything else. There is no way of deleting anything. You can't go and say, can you please go and delete my environment that I just put up, for example. Instead, that's all you have. Go up, 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 and if you need to delete it, then you have to manually go in and delete the resource group. That's it. So what does Bicep look like? Well, let's go back out here. I have an almost empty project. It is now empty. We'll do Bicep. We'll add a file in here called main.bicep. Like that. I have the Bicep extension installed in Visual Studio Code, which is quite neat, because it means that if I want to create an app server, a service plan, for example, which is called an app server farm in Azure language, we just go resource like that. It comes up and says, that's the keyword you want. Yes. What's the resource type you want? I want the server farm. What version of the API do you want to call? And I hate the fact that you have to add the version number in here, but actually the API changes over time to the point where it's not backwards compatible or forwards compatible. So we have to choose our version. So I'm going to choose the latest version like that. And I missed one thing because we need a name in here as well. App service plan. That's going to be, it's not the name of the resource, it's the name inside of this file, so I can reference to it. It's called a symbolic name. Then we can go like that, and then it says required properties. I love that. It tells me these are the properties that you have to fill out. We'll have a name in here, so I'm going to do my app service plan, and it needs the location. Let's do North Europe, like that. It's going to have a little yellow squiggly line saying that I shouldn't put in the location as a hard-coded string. I'll fix that later. And then we need to put in a SKU, so we'll do a SKU. I'm cheap, so I'm not going to pay for a standard one. I'm going to go with a basic one. And I'm not going to put a tier. I'm instead going to set in capacity, for example. And you see IntelliSense is quite neat, so it gives you IntelliSense for everything you want to do. 1. Properties. what else do we want to? Oh yeah, so it's going to be. Oops. I want this to order doesn't matter. Once again, I have OCD CDO, so you get the letters in the right order. But I need to have things in the right order, otherwise it irks me. So I'm going to have kind up here, and kind is going to be a Linux machine, and because it's Linux, the property reserved has to be set to true, because otherwise it doesn't work. So that's the syntax of Bicep. It's fairly simple. Problem here now, there are a couple of problems. Hard coding your name into your template file is a dumb situation, because if you want to spin up more than one environment, that's going to obviously fail. So we want to pull out the name, and we also want to make, with infrastructure as code, we want to make sure that we have a unique part of the name. So we want something that's uniquely generated so that if I redeploy it with the same name again, it still won't collide with existing resources out there, so that we can deploy new environments whenever we want. So I'm going to go up here and I'm going to create a variable, and we just go var project name, and we'll put that and say IaC Bicep. And then we'll say var suffix, because I want to have that unique suffix at the end of everything. And my suffix is going to be a unique string. And it's going to take in, and since I'm deploying to a resource group, I can use this method here called resource group, which will give me the current resource group that I'm deploying to. And unique string is it takes the ID of my resource group and hashes it into an 8-character long string that can be used as a suffix, for example. The reason for that is that we can't use random, because it would basically generate a new string every time, right? So every time you deployed, you would deploy a new set of infrastructure. So unique string will take some form of input, the ID being pretty good, and creating a hash out of that gives us the name that we want. And then I'll change the name here from my app service plan, and we've got string interpolation in here as well, so we'll do just like that. And then we'll do project name. We put a little dash and then plan maybe, and then we'll do suffix at the end like that. So we just build up the app service name that we want like that, which is pretty sweet. And we can actually, if we want to, even better, pull it out here and say app service plan name, so we have it in one place. Take that out, put it in there, take that, put it down there. So it's a bit more like writing code than it is when you're using ARM templates. And then location, well, location we don't want to have like this. So we want to have var location. We want to put that into a variable as well, so we can change it. And then we'll do resource group location. I'll replace that with that variable instead. Still, it's going to tell me that, hey, you shouldn't actually be doing this, blah, blah, blah. I don't care. I'll fix that later on, later problem. And then afterwards, and this gets really boring with my demo. I'm really sorry about that. But once you've gotten to this point, the rest of your life in infrastructure as code land is just resource, resource, resource. It's boring, to be perfectly honest. So I've hard-coded it, or I've created snippets for that. So we'll just do Bicep1, create a web app. I'm going to pull up the name. I like having all the names up the top so you can see where they are. And all I'm doing is creating a web app. But as you can see here, server farm ID, I point and I can actually use my server app service plan dot, and I can get properties and information from that. So compared to ARM, where you have to do string concatenation and weird stuff like that, we don't have to do that. And then we'll do Bicep. Actually, I want to have some in application insights in there as well. So we'll add some application insights in here. What stuff happening? Like that. And then I want to use application insights with workspace. And there are a couple of things with that. Mostly that I need a workspace. So we'll do workspace like that. So I'm going to create an application or operational insights workspace. So the log analytics workspace. I'm going to create my application insights. Put that name up here as well. So I got my log analytics workspace, my application insights resource pointing to my log analytics workspace.id, like that. And then we need to insert into my app service, I need to set instant configuration for application insights for that to work. So what I'm going to do is I'm going to create down here Just going to add an app settings. And the app settings is going to be app insights instrumentation key, and to get the value for that app setting, I just pull it out from my application insights resource. So once again, it actually gets really boring. We need a storage account, so I'll do a Bicep here because I want to have a storage account. Create one of those. Storage accounts are a bit annoying because the naming of them means that it has to be lowercase, it can't have any dash it has to be less than a certain amount of characters and stuff, but we have these two lower and replace functions and things that we can use to create the string for us. So that's kind of neat. And then we need to add that connection string to my storage account into my app service as well. So I'm going to go in here and I'm going to do connection strings. That's going to complain and say it's not allowed because it's not supposed to be there. It's supposed to be there. Connection strings is kind of like app settings. The only difference is that you have to set a type, which is going to be custom for storage. You give it a name, and then for the actual connection string, there's no way to get the actual connection string out of Bicep, unfortunately, so you have to build up this massive connection string, and at the end here we pull out some default suffixes that we can get from Bicep, but then at the end we also need to pull out the keys, and that's done with some built-in function called list keys. So all of this is pretty well documented. You just Google Bicep connection string storage and they will tell you, and then you copy it, which is kind of what I've done. Anybody that gets on stage and says that their code does not come from Google is bullshitting you. Okay, what else have I done? Oh, I need to make a change up here. So we don't want to hard code things. I said that to begin. So we want to change this. So this is now going to be, I want to have that as an input so that when I run my Bicep, I can pass in that variable instead of having hard coded. So we'll make it a parameter, and we're going to make it a string. And I'm going to remove the default value. And I'm going to turn location into a parameter as well of type string, but I'm going to leave it having a default value as well. So it means that we can now pass in the project name and the location, and if I don't pass in the location, it's going to use the default location of the group that I'm deploying to. And finally, the last thing that I want to do in my Bicep is that once we've deployed our application, we often want to get some information about the environment we just created so that we can use it later on in our pipeline, right? Now we do that using outputs. So if we go down here, I can tell Bicep that I want to have an output called website URL. And then I build up the output that I want. And then once I run this, I can then ask the Azure CLI that, hey, for this deployment, can you give me the output called website URL so that in a pipeline, for example, I can go and pull that out and reuse that information later on. That's it. That is the syntax of Bicep. It might be a little bit overwhelming when I do a Bicep file like that in 5 minutes, but you get the gist, right? You get the general idea, and then you go home and you Google it, and everything is going to be awesome. Once you got your Bicep, you go and say IaC, let's see here now, group, create. So I'm going to create an Azure resource group. Hopefully that's going to go about that quick. And then we do IaC deployment group. Nope, not that command at all. Create, that's the one I want. So I'm doing an IaC group deployment group create. I tell it that I want to deploy to the group called IaC Bicep that I just created. I give it the address to my file, which is now in the same folder that I'm actually located. So it's going to be that path. And then I do a -p, which is a parameter, and I say I want to set the project name parameter to IaC Bicep. Run that, and hopefully that's going to run in the background. Hopefully just work. Yeah, there it is. It's running now. I'm going to go back to the slides while that runs because we don't want to sit here and look in that ugly ASCII spinner for the entire time. But I'll get back to that at the end. So if we go through, so extensibility when it comes to Bicep. Well, not a whole lot, to be perfectly honest. You can go in and you can create modules, and then you can take those modules. So basically a module is just a Bicep file or a template that you basically store on GitHub, or you share it in some other form, and then you can basically point towards that and say, so you can group a bunch of resources and say, I want to use that template over there with these parameters. That's it. No more extension points. You cannot plug in anywhere. You can't do any weird stuff, which might be awesome depending on what kind of a developer you are. Are there any unique features in Bicep? Yes. You can see your deployments in the Azure portal, which is quite nice. So if you deploy, you can then go into the Azure portal to your resource group and say, go to the deployments group, and it will show you that your Bicep deployment has succeeded, and you can then go from there to click in and see what actually happened, what are all the steps that were involved in the deployment and so on, which is quite nice. It has a cool VS Code extension that I just showed you, but even better, if you, which most people tend to have, already have an environment that they want to convert into Bicep or some form of IaC, you can go into Visual Studio Code, you press Control-Shift-P to pull up the palette, you search for Bicep insert resource, it gives you a text box where it asks you for the ID of a resource. You give it the ID of the resource and press enter, you wait a little while, and it spits out the Bicep needed to create the resource that's already available in Azure. So you can reverse engineer your existing environment into Bicep. Woohoo! I wish I had had that a couple of years ago when we built a big environment that already existed. And it doesn't have any custom state, so there's no way where it stores the state of your current system. It looks at the state in the cloud. So when you go and do a deployment, it looks at what you're requesting and compares it to the world as it looks today, and then figures out what to do to make it match. That might not make a lot of sense if you haven't worked with infrastructure as code before, but when we get to Pulumi and Terraform, you'll see that they actually have separate state management to keep track of what's going on in your environment now compared to your current this situation that you want. And it has 0-day support for everything for the very obvious reason that Microsoft is basically building Bicep, or they're building Bicep on top of ARM, which is building on top of, well, Azure. So as soon as Azure adds a new feature, you can start adding it to Bicep. It's that simple. Are there any annoyances? Yes. It cannot remove an environment. So you can't go and say, spin up this environment on this Bicep, and then please go and remove everything you created based on this Bicep file. That doesn't exist. It is go and spin up everything, and then it just looks at you and goes, yep, your problem now, and it bucks out the door. So you have to go and remove it manually when you want to remove an environment. You have to put the version numbers in there. Not a big thing. It just annoys me with the version numbers. And then you think, oh, there's a new version, I can just update to a newer version because it's backwards compatible. No, it's not. So keep your versions, they are there for a reason. I just don't like the syntax of it. Okay, has my application deployed or my environment deployed? Ta-da! I get a bunch of output here that shows me everything that was created as such, but it has created everything, and if I open up and I browse over quickly to the Azure portal, that might take a while because the internet here is a bit weird. Okay, I can show you one more thing while that runs. We can go AC, deployment, what is it called? Group show. So here is a command I can run now. It's like AC deployment group show. So show me the deployment for the resource group called IaC Bicep. The name of the deployment happens to be main because it defaults to the name of the file unless you name it specifically. And then I can add a query and say, can you please output the properties.outputs.website.url.value? And if I run that, it's going to give me the output that was in my Bicep file. So I can get the URL to the website might not be useful, but if you auto-generate all of your resource names, you're then later on in your pipeline going to have to deploy to something, so you will have to get the name of your web app or whatever to be able to use it further on. So that's kind of useful. And in Azure, if we go and look at my resources, so I'm not faking it, IaC Bicep, and here are my resources. It might not look very good. So here you can see a little bit of it. Not really because it's dark, but there are resources there for the people in the back. And they have a unique name appended to the end of it, or a unique suffix. Okay, so that's Bicep. Let's go on to Terraform. Terraform is probably the kingpin of the industry at the moment when it comes to infrastructure as code. It's everywhere, it's huge, it's been around forever, and it's not bad. So let's have a look at the same steps for Terraform if you want to get started with that. So How do we get started? Well, you install the Azure CLI, because Terraform builds on top of the Azure CLI, so you have to have the Azure CLI installed on your machine anyway. So by now, you're halfway to using Bicep already. So you could just quit here and go back to the Bicep slide if you want to, and you'll be done. If you want to do Terraform, oh, you need to log in as well. If you want to do Terraform, you need to install the Terraform binary, which is a little bit odd depending on what kind of a environment you're on. If you can download it and you can add it to your path, or you can install it in Windows using Chocolatey, or you can use Homebrew on Mac, or you can use whatever Linux package manager you're using if you're using Linux. And then you write your Terraform template, and then you run Terraform init to say that this is a Terraform project, and then you run Terraform apply to create the infrastructure. That's about it. That's how hard it is to get started, and that's honestly not that hard. The tool demands a bit more out of you, so there's not just one or two commands, there are a few, and these are probably the most important ones. So the init one is one that Terraform turns your application or your project into a Terraform project and downloads some binaries needed for your providers and things like that. Because Terraform supports more than Azure, so it needs to download an Azure provider and a few things like that. So you run that once at the beginning, and then you're pretty much done. Terraform validate is the same as, validate will look at your Terraform file and just validate that it's syntactically correct. So if you just want to verify that the code that you've written isn't wrong, you'd run that, and it says, yes, it's fine. Terraform apply is the same thing as group deploy in Azure, in Azure CLI. So it applies your template. Plan allows you to run through your template and say, based on the current situation, what is going to happen? And it will show you the output, and you can save that plan and then deploy that at a later stage. So for example, if you split your builds and your releases, you can, in the build phase of your deployment, go and run Terraform plan and save the plan. And then in your release stage, you can go and release that plan. So even if stuff has changed in the code in between and so on, you can go and run the specific version that you ran in your build. Destroy, woo! You can delete your environment. So if you spin up sort of PR environments or anything, you can just do Terraform destroy, give it a Terraform file, and it goes poof, environment gone, which is really neat. Terraform refresh pulls out some, basically refreshes its own state compared to the state that's in the cloud now. So there's a bit of state management going on, which can be a bit annoying. And then you have Terraform FMT format. So if you go, Terraform works on the idea of a folder, and everything inside of a folder is considered a Terraform module, and it basically looks at all TF files in that folder. If you go into a folder with Terraform files and you run Terraform format, or FMT, it will format all of your Terraform files into this really nice syntax where all equal signs line up. So it basically space separates everything, so you get nice columns inside of the, I know, it's so beautiful. Okay, so what's the syntax like when it comes to Terraform? Well, let's go, if I can close this down. I'm going to do this quickly. I see I've got a little bit of time, but we'll figure it out. There it is. We'll do new folder. We'll do Terraform. That was ugly. That was ugly. Terraform, new file, main.tf, we'll call it that. And since I've already shown you what I want to set up and everything, I'm not going to write a bunch of stuff in here. I'm actually going to cheat a little bit and use snippets for everything. But the first thing you do in your Terraform file or Terraform module is you say, what provider do I want? What environment do I want to create infrastructure in? In this case, I want to use the Azure Resource Manager provider because I want to build up Azure infrastructure. You give it a version. And then you have to give it a provider configuration with an empty features block, because if you don't, it breaks. And if you add that, it makes no difference code-wise, but it doesn't break. Don't ask. Once you have defined what providers you want to have, you need to tell Terraform that you want to have those providers. So we'll go into the Terraform folder and run Terraform init. And when it does that, it figures out what providers is in there, and then it goes to Terraform and downloads the binaries for it and puts it into this folder here. And when it manages to do that, we also enable IntelliSense. So if you have the Terraform extension installed, IntelliSense all of a sudden starts working. So to create a resource group, you just write resource. Kind of that. Thank you, Copilot. And then you can name, so you tell it, and if you go in here and if you run, okay, so if you look at this, it does have IntelliSense, so it gives you all of the different resources available from the Azure provider. You give it a symbolic name, so syntax-wise it's very close to Bicep. The difference is that the symbolic name is at the end instead of in the middle, and you don't have to put in a version number. And then you can go in here and we can give it a, let's see here. I want to have some inputs. Sorry, I missed the input part. I want to have TF02. So in Terraform, they call it variables. So inputs are parameters in Bicep. They're called variables in Terraform. You give it a type. You give it the default value. It can do pretty much the same as Bicep, so no difference. Syntax is a little bit different. And then down here for the name, we'll go ahead and write var.project name. I don't know why I'm not getting IntelliSense now. Oh, now I'm, okay, so var.location. So we get IntelliSense for things that we have declared as well. That works fine. I want to have that unique suffix things as well. And the simplest way to do that in Terraform is that you add a random string. So I'm creating another resource here called random string. The type is random string and it's called suffix. I want to have 5 characters, no special characters, just letters and numbers. And then once you have that, we can go and add, instead of having variables like you have in Bicep for all of the file names, or sorry, the resource names, what you do in Terraform is that you create what's called locals. So they're called locals instead of variables, not a big difference. Syntax-wise, it's double quotes instead of single quotes. Other than that, you've got the same interpolation syntax and everything. When you want to reference, for example, this resource here, the random string resource, you first go the type that you want to reference, and then the symbolic name of the thing that you want to reference, and then the property on that thing that you want to reference. So it's type, symbolic name, property. Now you also have lower and replace like you would in Bicep as well. Okay, after that we're back to the boring old, let's just add some resources. So I'm going to add a log analytics workspace, and just for the heck of it, I can show you here that you get full IntelliSense for all of your properties and things like that on that as well. So we'll do TF06 for application insights. We'll do, and yeah, here you can see another one, Azure RM log analytics workspace. That's the type, that's the name, the symbolic name, and that's the ID that I want to pull out of it. So that's the way we reference things. TF06, log analytics, no. TF07, maybe, there it is. So I do a storage account, we do a service plan. They look pretty much the same, so that's why I'm just chugging this out there because it is really boring. We do a web app. But they actually call it a Linux web app, so I don't have to say that the kind is Linux and all of that. They have a separate resource for each one of them. And that's because they build on top of the Azure CLI instead of on top of ARM. And when it comes to instrumentation key, I can get hold of that in the same way as I did before, but when it comes to the blob storage connection string, Bicep, I had to build up the string. Terraform, they are nice enough to give me a primary blob connection string that I can just use straight up, which is quite neat of them. Thank you, Terraform. And the last thing is my outputs at the end. So they also have the support of outputs. So I just do a string interpolation thing down there at the bottom, and I got my output. That's pretty much it. Once I'm done with that, I can go back out to my trusty terminal. That was not my trusty terminal. That's my trusty terminal. Now we do Terraform init again. The reason I have to do Terraform init again is because I started using the random string provider, so it needs to download that for me. And then once we've got that, we can do Terraform deploy, no, Terraform apply, sorry. That's the one I want. I can pass in the project name, IaC TF for Terraform. I run that. I run that. I run that. That runs in the background. Let's just leave that. It's going to run in the background. I'm just weird that it takes that long to run. I don't know why. Okay, so I'm going to go there. So what's the situation with extensibility when it comes to Terraform? Well, You can create modules. Modules can be put into GitHub and shared or other source repos, so you can share modules with and reusing sort of combinations of resources, just like with Bicep. You can use provisioners, which is really nice, saying that when this resource is created, I want to run this command as well. And then you have something called null resources, which is basically a non-existent resource. But you can get a non-existent resource with a provisioner on it. So if you want to go, if there's something that's not supported, you can go and run the Azure CLI to do a custom command as part of your deployment and do like an up and down based on a resource that doesn't actually exist, which is a weird way of doing it. And if you like Go, you can go and write your own custom provider, which is really, 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 really cool and really, 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 really out of my comfort zone when it comes to Go. So I'm not going to show you that at all, but you can. Are there unique features? Yes. Terraform has what they call a CDK, which means that you can actually define your Terraform stuff as C# or TypeScript or Python, which is kind of cool. So if you want to code your way through it instead. And they have a huge marketplace with providers. I think they have somewhere in the range of 1,700 providers or something ridiculous like that. So if you want to go beyond Azure, you can do so much more with Terraform of setting up different environments and different things. Like you can go and configure your Okta deployment, or you can go and set up your Azure DevOps pipelines, which you actually can, I think, partly with Bicep or will be in the future. But there's a lot of other stuff you can do with Terraform. Annoyances? Yes, they have a shit DSL in some cases. Sorry, I shouldn't have said that. It's being recorded. Beep! There is no if statement in Terraform. Why is there no if statement? Because you don't need one. And I'm like, how can you not need one? If I want to conditionally add a resource, you don't need one because we have a loop. And what's a loop from 0 to 0? Nothing. Yeah, that's the response. You're looking at me like I'm stupid. That's true. A loop that goes from 0 to 1 is true, and a loop that goes from 0 to 0 is false. So that's the way that you do a conditional resource in Terraform. You do a loop, and you tell the loop to either go from 0 to 0 or 0 to 1. Yeah. It takes time to get support, because once they have deployed it in ARM, it needs to be deployed to the Go SDK, and then after it's been deployed to the Go or implemented in the Go SDK, it needs to be included in the Terraform SDK, and then you can start using it. So it can take a month or two for new features to pop up. So if you want to be bleeding edge, that doesn't work. You can get around it with a new thing at the moment, though, called the IaC API provider. And it needs to have store state. So you have to have a state file, which is a JSON file, and if my application has deployed, which is just hasn't for some reason, you can see that you get a JSON file that contains like, this is all the stuff I deployed the last time I ran. And then it diffs your new state, your new desired state with that JSON file to figure out what do I need to modify to make it work. And once in a while, if you fail, you can end up locking up the state. And if you then have put your state in blob storage, for example, so that it can be reused and shared and used in the pipeline, it locks the blob file, and then somebody has to manually go in and unlock the blob file for it to work, which can be a bit annoying, but it's not that common. So now is when I was supposed to go back here and show you how cool it is, because it's set up everything up, and I have no idea. It's stuck. It just does not run. Please wait for Terraform to exit or data loss will occur. Yes, die. Did not work. Okay, so operation cancelled. Yes, pretty much for. So I'm not gonna run through that. I don't have enough time to run it a second time. But basically, it just starts everything. It's nothing that fancy at all. The only cool thing is that yes, it has outputs as well, but you can also do Terraform destroy, and it pulls everything down, which I really like. So the next thing up is Pulumi. I really, really like the idea of Pulumi. Somebody might have noticed I said I like the idea of Pulumi. Pulumi is cool, because the idea with Pulumi is that we get to write our desired state as code. So if we are comfortable writing C# or TypeScript or Python or X other weird languages, you can do that for your Terraform or for your infrastructure as code. So you can actually create a C# project, and in your C# project you say, this is what I want, and then magically Pulumi makes it happen for you. Getting started with Pulumi is fairly similar to Terraform. In the beginning, you install the Azure CLI. You log into the Azure CLI because it builds on top of the Azure CLI. You install your language runtime of choice. So if you want to use Node and TypeScript or JavaScript, then you have Node installed. If you want to run .NET, you have to have .NET installed, and so on. Most of the time, that's already installed on your machine, obviously. So if you're a .NET developer, .NET is already there. You install Pulumi, which you can do using Chocolatey, Homebrew, or a curl script on Linux, which is quite fine, not too complicated. Then you log into Pulumi. Terraform also has a cloud way where you can store your definitions and things. Pulumi has that as well, but you don't need to log into their service. You can actually log into your local machine and say, store the state on my disk. So I'm going to do that in my demo. And then you create a Pulumi project, which you do by telling the Pulumi CLI that I want to have a project, I want to run C#, and I want to target Azure, and they will give you a C# project targeting Azure, and you can start coding. And then once you've coded up what you need, you say Pulumi up, and then magically it just appears 7 minutes later. It's fairly similar to Terraform, to be perfectly honest, in a lot of ways. You got Pulumi login, which is a little bit different than Terraform, but you got Pulumi new to create a new project. You got Pulumi refresh to refresh your state from Azure. You got Pulumi up to create something. You got Pulumi destroy to take something down. But you also got Pulumi stack, which is really cool. Pulumi has the idea of stacks. A stack is a set configuration. So you can basically have configuration in Pulumi to have different environments. So you can have a dev stack and a prod stack and everything. And every stack is also encrypted. So you can store secrets in there and things like that. And you can define who is allowed to deploy what stack and things like that. So it's basically includes configuration in the project as well. So a quick demo of how that works. It looks like this. I'm just going to go, actually that wasn't what I wanted. I wanted to go here. Terraform was a fail. Bicep was so far a success. Let's see what Pulumi does. We'll do a Pulumi folder like that. Actually, I'll go back out here again. We'll do a cd Pulumi. We'll do Pulumi new Azure C# because I want to do an Azure project with C#. What's my project name? Let's call it IaC Pulumi. Description, don't care. Stack name, dev. Passphrase for encryption. And then where do you want to store it, or where do you want to create it? I'm going to go North Europe. And the cool thing here is I don't need to pass in my configuration when I run Pulumi up, because all of my config is instead inside that stack. So I can store my different configuration in different stacks, and I select what stack to deploy, and it has all the information there instead. There it is. If I go back in here, we go into my project. You'll see here there's a Pulumi YAML file saying that this is a Pulumi project, saying that it's a .NET project. It has a dev stack, and in here you can see that's the configuration value that I passed in. It has the encryption stuff in here as well. And in here, there's my project. So this is my code, and I'm going to remove all of this, and I'm going to write my own code. So I'm going to write the same thing that I did previously. But all of it runs inside of this Pulumi deployment run async. And everything in there is... And it doesn't create anything. So when I go ahead and I write var rg equals new resource group, like that, and I name it rg, that doesn't actually create a resource group. The important part here is it creates the desired state that I want to have a resource group, and then later on Pulumi will take that, whatever I have set up as my desired state, and go and fix it. So this doesn't run off to Azure to create the resource group as such. There's a little problem with the resource group here, because if you just give it the name here, the name of the actual resource is going to end up being that name plus 6 or 8 unique characters at the end of it. So it's going to actually do the suffix stuff for me automatically. So to be able to say that this thing actually, I want to give it a proper fixed name that Pulumi shouldn't change, I need to pass in some args here, and I'm going to give it a resource group name and say, I want this thing to be called, actually let's call it project name, and I'll go and fix that in just a second. Like that. Where am I going to get my project from, or project name from? Well, actually, I'm going to get that from that. So I'm going to go and pull up my config, and I'm going to ask my config, can you please give me this setting called project name? I don't have a setting called project name, so what I'm going to do is I'm going to go out here, say Pulumi config set, there it is. I'm going to set a setting in here. And if I go back here and I look at my Pulumi dev YAML, there's now a new setting in here called project name, IaC Pulumi. And I can read that in my code in here, so once again, I don't need to pass it in at some point later, and then I can use it in here. And the cool thing is, everything is C#, so you get full IntelliSense and everything, and once we've got our initial resource, we can just go ahead and say, here are all of my names for my resources. Once again, pure C#, nothing weird. We'll do log analytics workspace, nothing weird, except for the fact that I'm doing parent equals RG. Pulumi has the idea of parent-child relationships between resources. So basically, you can have a parent and child relationship. So this belongs to sort of a resource group. And we'll do application insights, storage. All I do is basically set up the default properties and set the parent. And it also has enumerations, so enums for everything that we need to set. That's basically fixed strings. What was that? That was storage. Why can't I remember this stuff? So I'm at 0.6. We'll do 7. It's just a lot of repetition. For setting the app settings, it's C#, so it's a little bit more cumbersome syntax with setting an array of objects and so on, but C# will help you with that. We'll do add connection string. Connection string is where it gets complicated, and I'm unfortunately running out of time. I'm already over. I'm really sorry about that. But I'm just going to... You need to do some weird stuff here because properties are asynchronous in Pulumi. So if I look at the property name, for example, here, you'll see that it's not actually a string. It's output of string. And the reason for that is that the name of the resource group won't actually be known until it's been created in the cloud. Name, actually it would know, but potentially there are properties that are only known once the thing has been created, so we cannot have and go and say, I want that property because it won't be known until it's done. So Pulumi has this idea of output of string, which is an asynchronous property, which for me is like poof. But that makes it complicated to build up my storage string, right? Because my storage connection string builds on top of other things that have to be created first. So I created this little helper method, and that is now going to be the thing that you think about the rest of the evening. I'm really sorry about that, but that's the way it works. So what we do is I created a tuple based on the two output of string names. So the names of the resource group and the name. And then I use something called apply to say that once you have this output has been created, or once the resource has been created, then I want you to apply this callback. Inside that callback, I create another output based on an async call called list storage account keys, where I give it the resource group names for the resource group and the account name, sorry. And then once those asynchronous things has come back, I do a continue with, and I pull out the key based on what came out of the other asynchronous thing. And then I take that output of string and feed that back. So I now have 3 layers of asynchronous shit going on inside of each other so that I can set the connection string. You know how I figured this out? Google. I have not been able to write that myself. There is no way whatsoever. But there is lots of really good information on the web for things like that. And if you're really good at asynchronous stuff, it's not that complicated. But it's a bit of a mind twister or mind bender. And then finally, output values you just return as a dictionary. And once again, the default host name for my app is an output of string. So I have to do an apply because that's an asynchronous thing. So I'm saying that once the default host name has been created, I will then go and take that value and do a string interpolation and return that as an output. So once again, asynchronous stuff. Last little thing here is you then just go out here and you say Pulumi up. It asks me for passphrase, and this is kind of cool because it means that different stacks can have different passphrases, so that you as a developer might have the passphrase for the dev stack, so you can deploy to the dev stack, but your manager might be the only one who has to develop the password for the production stack or whatever you want to have, so you can have these security boundaries. So I'm going to go and add my password. Then you can see here it compiles my project, and hopefully this will be really fast. .NET Build, it creates it, it runs through my code. That was really fast. And it basically comes up with, these are the things that you created in your code. Is this what you want to create? And you can go in and go deeper, and you can actually say details. And if you go for details, it tells you these are all your settings, these are all the names, this is all the stuff that I'm going to create for you. Are you sure you want to do that? You just select yes, and then it will go off and create it for me in the cloud, which is going to take a little while, and I'm not going to show you. So while that runs, I'm just going to quickly, sorry about being late. Pulumi, extensibility, well, it's C#, so you can basically create NuGet modules and share them on NuGet if you want to, and share them among your team. You can group resources into something called resource something, I can't remember the name of it now, so that you can reuse it, so you can create your own things. So basically you can create a website resource which creates not just a website, but it actually creates a website and log analytics and sets up CDN and adds TLS on top of it and things like that. And then with C# you can also add methods, so you can go and say create a website. Oh, by the way, I want to add a CDN to it. Oh, I want to add that to it, and basically slowly build up your resource, which is kind of cool. Yes, depending on your language, you can do completely dynamic things. So in TypeScript, I know, because I've done it, you can actually go and say, I want to create my own completely dynamic resource, and I want to go and write my own Azure CLI script, but it still plugs into Pulumi so that it goes up and down, so it can create, and it can update, and it can delete, and it becomes part of the state and all of that stuff, but you have full control, which is really cool. Local command is a tool that, or Pulumi command is something that just added, which is another NuGet package, which is kind of cool, where you can run your own commands. So basically, as part of your Pulumi deployment, you can also go and say, oh, by the way, I want to run Azure IaC something something and run an Azure command, or go and do something else with some other CLI or whatever, and still be a part of Pulumi as well. Unique features, programming language of choice, which is kind of neat. I like that. They've got the configuration system, so you've got the stacks, which is really, really neat. Day 0 support, because they actually auto-generate the SDKs based on the Open API spec from Azure, the Azure API. So whenever Azure releases something into the API, it's going to be in Pulumi, which is quite neat. Also means that all of the properties on all of your resources in Pulumi are 100% identical to the property names of your ARM and Bicep templates. So if you ever Google anything and you find an ARM template showing what you can do, you can translate that into Pulumi without any problems, because the names are identical, which is sweet. Annoyances, yes, output of T. If you are like me and you think asynchronous stuff can be a bit complicated, welcome to Pulumi. Bit slow. Well, it's already done, so no, it's actually not that slow. But if you start doing dynamic resources, it gets really slow. And I do that in all my other demos. So all my other demos has a long wait period. But if you stick to the default stuff, it's pretty fast. You can use the old SDK together with the new. So there are cool things in the old SDK, which was handwritten. And then you have a new SDK that's based on the Open IPA spec. So basically, you can do the default stuff in the new one, but if you go back to the old one, you can do add features that doesn't exist. You can, for example, go in and with Pulumi, go and upload a JavaScript file into a blob file and turn it into an Azure function, and all of that inside that thing. So your deployment doesn't just become set up infrastructure, it actually becomes deploy a blob thingy, create a zip file, set up your function and all of that inside of it. Only works in the old SDK though. And you need to manage state, which is a bit annoying, but yeah. So conclusion, I left this slide really, really short because I'm way over time. Use whatever you feel like. I'm really sorry about that. And the thing is, I really want to come to a conclusion and say that this is better. If you are on Azure only and you have no intention to go anywhere but Azure, go with Bicep. It's so simple to start with. It does most of the things. But if you ever think you might grow out of that, and you probably might in the future, because all of a sudden, oh, I need to do that thing as well, then Terraform and Pulumi will give you that possibility, which is nice. If your team is only developers, Pulumi is sweet. If your team depends on infrastructure people as well, they will hate you for doing everything in code, and they will probably stab you in your sleep. So go with Terraform. That's my suggestion. So sorry for going over. Thank you all for listening. The code for this talk is available at that address, and you now have a party to go to. Oh, and if you have any questions, I will be around for a short while, and then I'm going to get in my car and drive to Stockholm.